All right, good morning, everyone. Sorry for that delay in getting started. Might have a few technical difficulties here to check in on as we go through our speakers, but I'll get things started here. I want to say good morning and welcome to the May California Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you for those that have joined us previously and those that may be joining us for the first time. My name is Amanda Sheffield and I'm the Regional Drought Information Coordinator for NIDIS in California, Nevada, and I'm affiliated with the Cooperative Institute for Research in Environmental Sciences at CU Boulder. This webinar is co-hosted with the California Nevada Adaptation Program and NOAA CAPRISA team. We've designed this webinar series to be bi-monthly and to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and a recording and brief summary will be available on drought.gov and our YouTube channel later this week. We've got a great set of speakers today, and I will mention that we are doing things a little bit out of order compared to normal. Normally we do the drought and climate update and outlook and then research or other topics of presentations, but due to the timing limitations for our speakers, we're going to do the opposite. First, we're going to have Jeff Jenkins from UC Merced talk about the influence of drought on recreation timing and volume at California National Parks, followed by Scott Rowe, who's the Senior Service Hydrologist with the Weather Service in Sacramento. Before we get started, though, let me just give a few slides on NIDIS for those who may not be as familiar. Our mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources and assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We work to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of early warning information for drought risk management. We do this by building a national drought early warning system, or DEWS, and through advancing regional DEWS, or drought early warning systems, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make climate and drought science accessible and useful for decision makers. Some of the activities we do within the California Nevada Drought Early Warning Systems include activities like this, webinars, which fall under communication and outreach, but we also have activities on planning preparedness, observation monitoring, interdisciplinary research and applications, and utilizing predictive and forecasting information. Just a few quick updates I wanted to provide on things that you may be interested in as listeners. For those that are interested, the NIDIS annual report is now up on drought.gov. You can find it in some of the top news if you just go to the main homepage on drought.gov. And then I also wanted to quickly mention that we have quite a bit of new news stories and articles on drought.gov. You can find those by going to the news and events tab, clicking latest news. I also want to point out you can find past webinar recaps, such as webinars of these in case you can't find them. And I also included the link and QR code to sign up for NIDIS emails, because I did want to make sure you all knew that when you sign up for these webinars, you sign up for each one individually. And unless you opted in when you signed in, you aren't added to our listserv. If you get the announcements already, you are already getting you're on our listserv and you get our announcements for these webinars. But for example, if this is your first webinar and you didn't opt in when you signed in, you won't necessarily get the post-webinar recap sent to you or the next webinar sent to you. So you could either wait for the next one and check that box this time, or you can sign up on drought.gov for our different NIDIS emails. So you can pick different regions, the national newsletter, and you also can sign up for drought alerts, such as for your zip code, to know when the U.S. Drought Monitor changes or a new drought outlook from the National Weather Service comes out, or things like that. And then these are just quickly some of those news stories. As I said, there were too many to really focus in on, and I want you to share that we've had recent ones about a new drought response guide for health professionals, about our collaboration with the National Weather Service and drought information statements that they provide, new case studies on mortality risk and its relation to drought in the Northern Rockies and Plains, a new tool released in partnership with Climate Engine and the BLM to think about how they are using drought and vegetation information, a new study on rising temperatures that aren't producing expected increases in atmospheric moisture over our drier regions, as well as a few studies about fire managers and how they're using soil moisture data. The first talk that we're going to have here is a new story on the impacts of drought on California National Park visitation, and then also a new research study on climate change impacts on the snowpack decline since the 1980s. With that, I'm going to pass over to our first presenter. I'm hoping, Jeff, can you speak and see if we can hear you?
Yeah, I'm here today. Good morning.
Morning, we can hear you, great. I was gonna pass over the screen to you to share from your computer. Is that okay?
That'd be great.
Yep, there we go. I'm glad this worked out and I didn't have any more hiccups here.
Okay, so I just want to make sure I have it on the right screen. I think I have to drag it over. I have a couple screens going here. Can you see that?
Yes.
Okay.
We're seeing the
is that in
projector view.
presentation?
Yeah.
It's tricky with these two screens. Let's see from current slide.
Yeah, hit the swap there usually.
There we go.
That'll
do it?
Yep, great.
Cool. All right, great. Well, good morning, everybody. Today I want to talk to you about the influence of drought on park visitation. I'll be focusing on national parks today, as you know, throughout California, and then specifically looking at Yosemite, and I have a little teaser in there about Channel Islands National Park too. But this is also work that is ongoing with other projects at state parks throughout California and throughout the Delta. We have a project also looking at drought influences on recreation that is water-based. So the first paper that I want to overview today is Visitation to National Parks in California and the influence on annual and seasonal change during drought and wet years. So drought conditions have direct and indirect effects. Some of the direct effects include reduced snowpack, earlier peak runoff, and lower stream flow, lake and reservoir levels, all of which can alter the availability of outdoor recreation activities. Winter drought can reduce opportunities for snow-based activities, such as cross-country skiing and snowshoeing, but less snowpack can also have effects on stream flow and lake levels into the spring and summer, which can impact timing and quality of fishing. Drought conditions can also have indirect effects, such as impacting the vegetation, wildlife habitats, and scenic resources that are associated with recreation, that are the foundation of what people view and experience. And the likelihood of disturbances, such as wildfire, that may be associated with drought, may result in restrictions in certain activities, impacts to infrastructure, park closures, or degraded air quality. Whereas with wet conditions, although visitation is reduced on days with precipitation, many outdoor recreation activities are directly or indirectly water dependent, such as boating, fishing, and wildlife viewing. So we actually assess volume and timing of use through the lens of drought as a departure from normal conditions and in comparison to wet conditions. Here are the different parks in California that we looked at, and you can see there on the map on the left of mountain, arid, and coastal parks. In hindsight, I probably would have put Channel Islands in the arid category after we discovered some of the data, but that's a different story. You can see that most of the visitation to parks in California is happening at Yosemite, and there's really good visitation, moderate visitation levels at the other parks too, and they're overwhelmingly really seasonally dependent. But there is some variability in these parks too, which you can see in the plus minus 25% quartile there in the grayed out area. So what were our methods for this with park visitation and drought? Overall, park visitation data was looked at from 1979 to 2019. This data is available for any national park through the Integrated Resource Management Application portal by month. And this time period actually excludes the uncertainty of the COVID era, so we can more distinctly look at the influence of climate. And then we normalized this data to reduce influence of growth in attendance. And actually, the decade of the 2000 to 2009, there was actually a decline in national park visitation throughout the country. So that was important to account for as well. And then the other NPS lands in California for the study, like national recreation areas, were excluded for less reliable estimates of purposeful recreational use due to porous entries and pass-through traffic that is incidentally being counted. So each park was assigned an annual PDSI category to assess the difference in moderate, extreme drought or wet conditions. And we used a June, July, August monthly average for the lens to understand that through. So the annual PDSI category was used to group years and to assess months for relative comparison, volume, and timing between wet and dry years. And so what were the results here? For mountain parks, for Yosemite, Sequoia, and Kings Canyon, last and volcanic, we found that there's actually quite a bit of saturation happening, or people have expectations of when conditions are happening. There's such a high level of use, particularly at Yosemite and to some degree Sequoia and Kings Canyon, that the difference from year to year is not as much as it might be, because people are booking their lodging a year ahead of time, traveling from far away and coming here, and the drought is maybe not influencing their decision on whether to visit and when to visit as much as maybe with other parks. But we did see a decrease in really dry years and drought years, mostly due to the coincidence of fires and fire closures during those years. And then moving to arid parks, looking at Death Valley, Joshua Tree, and Pinnacles, you can see that the seasons are much different here, but that basically when it's much wetter earlier in the year in spring, there's much more visitation to Death Valley, which makes sense, just as with Joshua Tree. With Pinnacles, that's maybe not as much as the case, because they have a really tight corridor of trail system there, and some of it actually goes through this cave system that becomes completely flooded during really wet years. So there's some more nuanced reasons here as to why these parks have certain trends that are influenced by climate, but may really kind of come down to the infrastructure and the visitation patterns throughout the park. And of course, in Death Valley, in the middle of the summer, when it's a drought year, we're going to see far fewer people. With Redwood National Park, that was quite interesting. It's actually jointly managed by the national and the state parks, the three parks that constitute it. But in drought years, there was much more visitation, definitely statistically significant. And that was overwhelmingly in the earlier part of the year, but it does carry throughout the year. And that's because it's already a really wet area. And so if it's relatively drier, it actually makes things more accessible for people. With Point Reyes, there wasn't as much variability, and that might be due to the proximity to the San Francisco Bay Area, with just visitation being saturated or responsive for that area with conditions. And then Channel Islands actually had a lot of difference from the mean, departure from the mean between dry and wet years on either side. And this, I think, has a lot to do with the fact that it's actually a really arid place, a relatively arid place to begin with. And a lot of visitation there relies on the green up of the vegetation and subsequently the wildlife viewing that relies on that, such as with the kit fox and all the other species that have been reintroduced there. That's actually quite a unique story and restoration throughout California. So how do we interpret these findings? There's more highly visited parks like Yosemite and Sequoia and Kings Canyon are moderately sensitive to drought, given visitors' expectations of seasonal conditions and fire risk, and the lodging that I mentioned. Parks that are typically very dry, Channel Islands and Death Valley, or susceptible to seasonal precipitations and flooding, exhibit the greatest variability because of those more nuanced things like infrastructure and access and park closures, where they already have a lower visitation rate. Those have a disproportionate impact. And then parks with moderate visitation that are not in urban areas, that same thing goes. There's a higher impact when there's a closure or reduced use from drought or wet conditions that the economies there might rely upon. So how do park managers respond to, and how do visitors adapt to these things? So NPS seasonal event-based use limits could be important. That is, there's different strategies are needed in drought and wet years to avoid resource impairment and facilitate access. There's this standard of non-impairment or not destroying a resource before it is ultimately destroyed. How do we avoid that? And that's a statute under the Organic Act that the Park Service was founded upon. And so I think it's important to look at the timing, volume and the impacts from those and how they differ in wet versus dry years. You're going to have way more use in a dry year earlier in the spring as people are able to access more trails with less snow and less water. But those people are going to have a much higher per person impact with their trampling on those moist soil conditions and the compaction of vegetation. Whereas in a drought year, you're going to have overall more people with less impact, but it's still more people. And that will go throughout the year unless, of course, there's a fire, which ends up closing a park, which happens often in the late summer. And then there's different hotspots that can differ between spring and winter during these drought and wet years, and how to account for the spatial difference between drought and wet years on a more proximate level is really important. There's also experiential impacts, and people hold different expectations of when they can do things and where they can do things, and their own ability level, and how to cater to that is a question. And then there's also health impacts correlated with drought conditions, such as with smoke exposure from fire. And we actually came out with a paper recently about that and found that visitation is persistent to Western national parks in that people are not fazed by poor air quality, or rather they make plans so far ahead of time that, and the air quality, although poor from fires, might be better what they're escaping from. It might be relatively better, but poor air quality from smoke from fires actually does not impact visitation at all. It co-occurs when there's the most visitation. And so with all these considerations, we need to also think about how do visitors adapt, behavioral displacement, and moving on to different activities. So there's 4 different ways which displacement can occur. Either, people are choosing to do this, or they're displaced because there's an administrative closure, there's a fire closure, there's too much snow, etc. So one is spatial. People can find another place to recreate within or outside of the park. The other is temporal. People can shift to an alternative time of day or a completely different season. Contextual. People can change to more suitable recreation activities given different conditions. And full displacement. They can forego visitation entirely without making it up at a later date. So briefly, I want to touch on Channel Islands off the coast of California. And this was just kind of a fun thing I did. This is not published. This is maybe not the entire story, but this is something I included for a talk that I gave in Ventura when we went to Channel Islands. And basically, I'm curious because there's more variability between years of extreme wet and dry use in Channel Islands. What happens when we don't just look at the overall visitation, but what happens when we look at the overnight use, the camping, the overnight boat stays? Because with camping and with being on a boat, you're more exposed to environmental conditions. And so maybe the hypothesis is that you can, use is more sensitive to influences of drought or extreme wet conditions for overnight stays. And I thought that Channel Islands would be a great spot to look at that because of that huge variability with overall use. So I looked at backcountry camping data and overnight boat use. That is boating that's less than a mile from shore and is registered through the park. And the assumption, as I mentioned, is that it's much more sensitive. So let's just look at a couple slides. Basically, I end up coming across an interesting tidbit here, which is that in this main graph here, there's a lot of writing, but basically the years that had more overnight use, as shown in this graph, and the figure at the right also shows overall visitation with a similar trend. There's way more visitation at Channel Islands during the period of relatively wet conditions. There was a couple dry years in there, but overall 93 to 06 at Channel Islands specifically was relatively wet. And before that, there was less visitation. After that, there was less visitation when there was dry conditions. But also what was happening during those years was huge efforts for restoration, for reintroducing species, for buying out the land, for removing hunting privileges, for removing grazing privileges, for restoring that island to its natural intactness. And I guess I'm arguing that if it wasn't just coincidentally relatively wet years during those years of species recovery and reintroduction, that maybe it wouldn't have gone the way it did, so successful for the ecology of Channel Islands and the visitation that went along with it. And then looking at one more slide from that, I actually plugged those in, the backcountry camping, and I did these, relative to the size of each of them with the y-axis. The camping, backcountry camping's on the left, the overnight boat use is on the right. And what I found was that there was much more use in really dry years for backcountry camping, and there was much more use during moderately wet years for boating, which might simply have to do with the fact that there's not as many storms there on the water, which is kind of a confounding factor. That's not necessarily drought or wet. That's something that's emerging from those conditions. But anyways, that's just kind of a fun side story. Let's see if I can get through this other talk here, paper in the next few minutes. I also want to look at overnight, use of the Yosemite wilderness, also sensitive to environmental conditions, being that people are backcountry camping, carrying what they can on their backs there. We came upon a set of about 325,000 individual permit records between over the last basically 2 decades, from about 2000 to more recently. And I wanted to see in wet versus dry years, what is the difference in timing and volume, but also in location of where people are able to go with snow. And the background here, which I'll breeze through, is that we cover it in a more detailed paper side there at the bottom, if there's interest about it. But basically, Yosemite is unique in that their permit system is zone-based. So you can leave from a trailhead, shown in this map here, this black and gray of the park. You can see the different zones and also the trailheads there with the different points. And you basically can camp anywhere that the topography will allow you to, but people do kind of coalesce around hotspots. You can see in this map here with the different fire permits that are mapped from at a later date, but from 1972 camping fire permit records, that people tend to agglomerate around areas where there's views, where there's water sources, where there's a lake, where trails intersect. But either way, there's a path dependency, and there's a very limited set of options where people can go between these different districts that might be influenced by snowpack, and certainly are. A story that people talk about, but no one's put the data to it, so to speak. So you can see the snowpack data for Yosemite on the right. I'll just briefly say that snow droughts can develop via several pathways, including low winter precipitation or average to low winter precipitation coincident with warm temperatures, or frequent rain on snow events that rapidly deplete snowpack. In the past half century, mountain snowpack has decreased throughout the western US, and warmer temperatures are expected to shift snow accumulation to higher elevation and decrease the spatial extent and volume of snow cover. And so, you know, this is a decent set of snowpack data. Really, in some ways, we make up for it with the amount of permit data. So I do think our findings actually hold a lot of weight in terms of what managers can use. And let me go and just show you some of those things. First off, we wanted to provide the context of the different road opening and closing timing for when Tioga Road on that map on the north, and then Glacier Point Road, the smaller red line further to the south. Those are still currently closed for the season. People are searching the internet madly to figure out when they're going to open. They're typically, the park tries to open these roads by Memorial Day, which on the figures here on the left would be about, on the top two figures would be about day of year 150, right in the middle there. And that's more often the case for Tioga Road, for Glacier Point Road than it is for Tioga Road, because it's lower elevation. Basically, no surprise, we found a correlation between red squares there of drought years with earlier opening days in both those. And then on the bottom there, the length of the season, it wasn't always the case, but it usually is that the drought years have a longer season. You know, there can be a earlier into the season with early October snow or other closures for different reasons due to fire. But by and large, there's more drought years happening more recently than there was. And so the Tioga Road is open for about 2 weeks longer than it was 25 years ago, and Glacier Point Road is open for about a month and a half longer than it was 25 years ago. We looked at these different ranger districts, wilderness districts, shown here on the map by the different colors. And those are the different trailheads where we were able to disaggregate the data between to see the different patterns. The data is for the peak season and the shoulder season. And this data is analyzed through the lens of the annual percent of average April 1st snowpack taken from the Tuolumne Meadows Snow Survey, which is approximately 57 inches as a running average from 1930 to present. And we use a single measurement as a sentinel for snowpack across the broader region, given previous studies and the use of April 1st snow survey by wilderness managers as an indicator of trail access conditions. And so we partitioned it into near average, high and low snowpack years, and then found some differences between these districts given the different elevations and road closure influences on access. We found overall that there was more access earlier in the spring when it was dry, which was no surprise, and that there was usually though, that resulted in less access, less people using the Yosemite wilderness on average in those dry years later in the season due to things like fire. And then on the right, you can see that we broke this out by month to look at the variability in between wet in blue and dry in red per each month. And there's much more variability in the spring than in the summer, and then the late the fall, there becomes more variability with potential snowpack in October reemerging with snowfall enclosures, and then also with things like fire. That dot here showing the lowermost point in August is actually when the Ferguson fire occurred, and there was far less use in the park that month because people couldn't be in the backcountry. This photo down below is actually when I was on top of Half Dome during that fire. You can see the smoke that is wafting throughout the valleys there. And we actually didn't know the name of the fire or where it started or what happened because we went into the wilderness before it happened. And then over the course of 3 days, it just suffocated the entire of the valleys throughout the park. So it does make conditions less easy to bear when you're carrying your whole backpack. And then looking here at the differences between the different districts, we found that there was more use in Yosemite Valley in wet years because people are being displaced from the closures higher up and want to access the higher up stuff through Yosemite Valley. That's the same thing with Glacier Point Road. There's more use in wet years because they can't access Tioga Road and Tuolumne Meadows below there and panels C and D. You can see there's much more use in those areas in the dry years because of the fact that you can actually get up there, the road being open. So in some senses, a binary kind of open or closed type of thing. But when that happens, influences how many people go there. And there's much more use at Tuolumne Meadows because there's about double the use because of the capacity accounted for with backcountry use coming in and out of the park on the Pacific Crest Trail and the John Muir Trail. And then Hetch Hetchy receives more use in wet years also because of displacement from higher elevations. And I think I have a few more slides here. I'll go through this one. Just mention that this is part of the paper. We do look at the actual quantitative difference in snow drought impacts on overnight use, and also how high snowpack impacts overnight use for each of these districts, which have different qualitative descriptions in terms of trail miles and elevation and the things that people seek there. So that is kind of interesting too. You can look into that at a later date if you're interested. Happy to share that stuff. And then so in closing, what are the management implications for this? Seasonal drought status differences have important implications for staffing, budgets, use limits, biophysical impacts, experiential conditions, search and rescue, etc. As prolonged drought conditions persist and are projected to be more common in California and throughout the Southwest. Also, while snowpack in the Sierra Nevada is projected to become less variable with more years of snow drought, the annual timing of peak snowpack will become more variable. So further studies might consider comparing visitation with additional months of snow survey data to better understand intraseasonal variability associated with environmental conditions impacts related to human use among qualitatively different types of snow drought years. And that also might include looking at differences based on each trailhead, not just by district, and also looking at differences by each day of the year, not just by aggregating by month, to get more specific sense of how areas are impacted by snow drought. And this is just one park, so thinking about that throughout different parks will be important too. That's it for now. Thanks.
Thank you, Jeff. On that note, I think the one question that's come in so far, and listeners, feel free to enter more questions while you can here. We're going to do just questions now. Since obviously you featured here mostly national parks, do we have hard data on the influence on state parks, or is there a plan to do that?
Yeah, I'd be happy to talk to you about that. I'm actually working on a paper right now looking at just state beaches. About half of the state parks are state beaches or state coastal parks. And so that's just a start. Ideally, I would love to be able to integrate regional parks, county parks, state parks, national parks, because if we were to do those coincidentally, then we could find, create a model of displacement for how people just aren't being, not going to one park or another, but how maybe those conditions in the mountains are creating an influence on people overall for more visitation to the coast during a particular year. But yeah, state parks along the coast are something that I'm thinking about a lot right now. And also looking at state parks in the Delta is interesting too. I'm doing that because that's really highly hydrologically regulated area, right? So is there an influence? And it turns out there might be a little bit of an influence, and that a lot of that has to do with salinity. When there's less water coming off of the Sierra Nevada, there's more saline conditions in the bay from the influence of the salt water, and so that has impacts on people too when there's more drought there.
Great. Yeah, that makes a lot of sense. The only other main question I see is actually more of a comment. Someone said nice half dome photo. And if anyone has any other questions, we can always follow up by email. I'll have my email at the end, or we can contact Jeff, or whichever way you would like, if anyone has any remaining questions. Just for time, we're going to go ahead and switch to our next speaker, who is Scott Rowe from the National Weather Service Weather Forecast Office in Sacramento, and he's going to be presenting on the Drought and Climate Outlook and updates.
All right, good morning, everybody. Give me 1 second, I'll share my screen. All right, should be sharing. Can everyone see it?
Yep, you're good to go, and I can see your little circle pen too.
The laser, awesome. All right, well, thank you very much for inviting me to present today. My name is Scott Rowe. I'm the Senior Service Hydrologist with the National Weather Service in Sacramento, California, and here to talk a little bit about the work here at the Weather Service, and then what we saw this last winter and what we can possibly see over the coming months. So first off, I'll just quickly start off about what the NWS office structure is like in California. Many on the call may be familiar, but for those that do not know, each weather forecast office with the National Weather Service is responsible for their specific set of counties throughout the United States. There are 122 weather offices throughout the United States, 10 of which cover portions of California shown on this map on the left. My area of responsibility at the Sacramento office ranges all the way from Shasta County in the north down to Stanislaus County in the south, so covering all of the Sacramento Valley as well as the western flank of the Sierra Nevada. Being in Sacramento, we're co-located with various offices. We're the state liaison office and co-located with the California Nevada River Forecast Center. So they're the federal entity that issues river forecasts throughout California and Nevada. We're also co-located with the California Department of Water Resources, which does a lot of the water forecasting and regulation throughout California, of course. And then our Sacramento Weather Service office, we have approximately 23 employees, including meteorologists, meteorological technicians, electronics technicians, hydrologists, which is me, and then other support staff that help fulfill the mission of protecting lives and property. So diving into the presentation, at least that I have today, first I'll talk a little bit about the wet season in California, a little bit of background information on that. So many may already know, but in case you don't, California has one of the most distinct wet versus dry season delineations in the United States. Easy way to take a look at that is just taking a look at monthly normal precipitation. For example, Sacramento Executive Airport, right down the road from where I am at. As you can see, very clear wet season in the winter months. January through about March are the wettest months of the year, dries up in the summer months, and then picks up again at the start of the new water year. So just for comparison, during the 5 wettest months of the year, which start from November, December, January, February, and March, 82% of all of Sacramento's precipitation falls in that narrow 5-month period of time. On the other hand, once you hit the summer months, the 4 hottest and driest months of the year, only 2% of our normal annual precipitation falls during that period of time. And usually if we get any precipitation during that time, it's a result of monsoonal moisture that may be coming north from Mexico, a remnant tropical cyclone that also is coming up from the north. Oftentimes we can go completely dry for 4, 5, 6 months at a time. I believe the record for the driest streak in Sacramento is over 200 days. That was actually set several years ago. Another thing to point out about California's wet season is each year in itself is unique. We like to joke that it's normal to be abnormal in California. It's very rare that you hit an absolute or that you're very close to normal. You're either way above normal as indicated with some of these dots here on the map, or it can be very dry, as you can see. If you fall very short of normal many years as well. It's just very uncommon that you get yourself close to normal. You either go above or shoot yourself short. So And another implication of our wet season too is, of course, it's unique depending on where you're at. So the far northwest California coast, for example, wettest parts of the state where they can easily get over 100 inches of rain in the coastal range in far northwest California, Humboldt and Del Norte counties. Also depends if you're in the desert or inland, so the Mojave Desert in far southeast California, some of the driest portions of the state. Death Valley is the driest place, less than 2 inches of rain annually on average. You can see the Central Valley as well. So my forecast area, some of the cities include Redding and Sacramento. Big difference north to south even. Redding gets roughly 33 inches of rain per year. You drop it down to just north of 18 inches for Sacramento. You just keep diving south into the San Joaquin Valley, Fresno, and Bakersfield. Much less precipitation in a normal year compared to Sacramento as well. So a very diverse state, geographically, hydrologically, in about as many manners as you can be. And as a result, of course, many of these intricacies of California's hydroclimate and the demand for water resources result in significant state and federal regulation of the water resources throughout the Golden State. That's why we have all the dams, all the levees, all the bypasses and weirs to help route water, help prevent flooding, as well as supporting the agricultural communities as well throughout California. So these are just a sampling of some of the photos throughout California, what you may find with water structures. So now a quick recap of this last water year, this last winter. For those in California, may have thought of it as you may think of it as a lopsided water year, depending on which half you're looking at. So when the water year started on October 1st and through about Christmas time, it was relatively dry. As you can see this image in the upper left, all the atmospheric rivers, or nearly all the atmospheric rivers, targeted the Pacific Northwest, Oregon, and Washington State, with very few systems impacting the California coastline. This resulted in below normal precipitation for the northern Sierra Nevada, as indicated in this graph for the months of October, November, December. What was observed is this light cyan color, and then the normal precipitation, what was expected for that month, is the solid blue line. So as you can see, we fell short of normal for those 3 months. However, once we hit New Year, things reversed. We got very wet very quickly once we hit the calendar year 24. As you can see, plenty of atmospheric rivers targeted California, many of which seem to have occurred on the weekend. So, and as a result, we did see above normal precipitations for the months of January, February, and March in the Northern Sierra for this 8-station indice. And then April and May, things tapered off quite quickly, a little bit below normal for those months, but recall from several slides ago, the bulk of precipitation, the bulk of our normal precip falls November through March for at least Sacramento and much of California. So the net result, we'll call this an abnormally normal year. Normally we are abnormal, but it's the opposite this year. So not too many years that we can find ourselves very close to normal as we are now. The 8-station indice for California, or for the Northern Sierra, is indicated with this bold blue line right here. We're up to 47.2 inches with that represents 93% of normal precip for the date. And then the pale yellow, or not pale yellow, pale blue color represents the normal curve, as you can see. So just short of where we should be for the time of the year. And by the time we hit October 1, pretty much again, the next several months are the driest periods of time for California. So not much more to make up for the small deficit that we have, but overall still a very good year, especially coming off the heels of a very wet and very active year in the prior water year. And taking a look at the snow water content, similar story to the precipitation up and down the Sierra Nevada, very close to normal, if not maybe a little bit above normal for the Northern Sierra. And then everything has been melting over the last few months. Of course, we're down to about 29% of the April 1 normal as of today. So a little bit more snow to melt over the coming months. It's not going to be nearly as long of a snow melt compared to last year, which is in that's what's represented by this thin blue line right here, was the massive snowpack that we saw last year. As you can see, north, central, and south, huge snowpack was observed that last water year, which of course resulted in many impacts throughout California. And as the snow melt trickles into the reservoirs are in fine shape throughout the state. This image is from the California Department of Water Resources, some of the major reservoirs that are operated throughout the state, both federal and state owned. As you can see, nearly all of these reservoirs are at the historical average for the state, some of which are even at or very near their maximum capacity. And I wanted to focus in specifically on Shasta, which is the largest dam in California, reservoir in California, far northern part of the state. And just comparison to what it looked like a year and a half ago before we entered that really wet year in water year 23. As you can see the outline, you can see the bathtub rings practically from space on this Sentinel-2 satellite imagery. And then over the last 18 months or so, the amount of inflows have allowed the reservoir to rebound quite nicely. And you can see a stark comparison from August 2022 to May of this year. And of course, the Drought Monitor. This is the latest image from the US Drought Monitor for California. Just a little sliver of far southeast California that encompasses parts of San Bernardino County and Riverside counties with D0 abnormally dry conditions. Elsewhere, no drought conditions have are depicted as of this month, which is great news, of course. Now, transitioning from a recap of this last winter and looking ahead for this current summer. The big talk that folks may have already been on the news is the dissipating El Nino that was in the Pacific Ocean this last winter. This was an image of sea surface temperature anomalies in late January, early February. As you can see, some of these anomalies peaked, of course, in the Niño region that we take a look at. And since have been waning, and we're expecting a 70% chance of the formation of La Niña by late summer, with even higher probabilities of the continuance of La Niña by the time we hit next water year as we get into the new wet season for California. So the probabilities on this graph essentially are represented for the chance of La Niña during these 3-month period of time in this blue bar. And as you progress through time into the summer months and then into the fall, you can see those probabilities for La Niña do increase. And then the latest Climate Prediction Center outlook I'll just focus on the United States as a whole, and how this should be interpreted, at least on the left, the seasonal temperature outlook for the 3-month period of time, June, July, and August. There's higher probabilities, higher odds that much of California, or all of California, will experience above normal temperatures during that 3-month period of time. That doesn't mean that there will be periods of time where we go below normal for a week or so, periods of time where we're way above normal, but the overall probability of being above normal is higher than the probability of it being below normal for the extended period of time. And on the right side, I want to urge caution, I guess, with the precipitation outlook, mainly because normal precipitation for California once you hit the summer months is near zero. Really, the only precipitation that we do receive in California during this period of time would be monsoonal moisture or remnant tropical cyclone moisture as it advex northward. But one thing that may be able to be interpreted from this image is perhaps the slow development of a monsoon season in the desert Southwest. We'll have to wait and see how that materializes. For my part of California, north central California, we generally don't see monsoonal moisture if it materializes until the second half of summer. This potentially could have some implications for those in the desert Southwest too, depending on when the monsoon season materializes and just how much precipitation comes along with that, of course. And then progressing into the second half of the summer, more into the fall as well. The images really don't change from the previous slide. As you can see, heightened likelihood of experiencing above normal temperatures for California during the months of August, September, October. And then near equal chances for precipitation in the northern half of the state. There is a contour to creeping into far southeast California with the below normal chances of precipitation. And again, this is likely associated with impacts from the monsoon season that the Climate Prediction Center is trying to highlight. And then just a few things with heat and fire resources that we have at the Weather Service to highlight as well. Big thing, of course, in California is the summer heat. One thing that we use at the Weather Service is a product called Heat Risk, which is a color numeric based index that provides forecast risk of heat-related impacts to occur over a 24-hour period. Essentially, green or 0 represents no heat risk. As soon as you get to the red and magenta colors, that means extreme heat risk. Don't really see that too often. Of course, reserved for those very hot days. But one thing too to keep in mind with heat risk that I wanted to point out is that it takes into consideration how unusual the heat is for the time of the year. So for example, if it were to be 105 degrees in Sacramento in May, that's very different than 105 degrees in Sacramento in say July or August. Additionally, heat risk takes into consideration the overall climate of the region. So if it were to be 90 degrees in Sacramento today and 90 degrees also in San Francisco on any given day, the heat risks for one location to another would be very different just because Sacramento is climatologically much hotter than San Francisco. Here's a great resource where you can check out the heat risk over the next 7 days throughout the United States. This is a relatively new thing for the entire country. Previous to this summer, heat risk was only a Western region centric product, but it since has unrolled to the entire country. You can click on any location on the map and get a 7-day weather forecast with the highs and lows, as well as the heat risks highlighted on the top color here. And at least for California, another rule of thumb that we follow at the Weather Service too is we tie heat risk to our legacy heat products. So essentially, when we start to see a lot of widespread red and magenta colors on the heat risk map, our office may be inclined to be issuing excessive heat watches or excessive heat warnings. If there were to be more widespread orange and red colors and no magentas, we might be leaning more toward heat advisory criteria. So, and this is a uniform policy that all of the California offices follow, which I showed earlier, the map of the California offices. So it's something that we take into consideration for those heat impacts in the summertime. And then another thing to highlight, of course, in addition to the heat, are the fire concerns as we head into the summer months and the dry season. Weather Service issues 2 legacy products for fire. Fire Weather Watch typically means that meteorologists are watching a situation that may lead to critical fire weather conditions, generally in the 2 to 4 day time frame or so. And then once forecast confidence increases as you approach the onset of an event, that would be upgraded to a red flag warning. And so as a reminder too, when I talk about critical fire weather conditions, that means that we're expecting low relative humidity values along with high winds, or just the potential of lightning with those receptive fuels, which could be in a dry lightning event, for example. And then taking a look at past fire seasons following a wet winter or above normal winter, however you want to classify it. We'll look back at 2017, 2019, and 2023, with the most recent, of course, 2023 being a very quiet fire season for much of the state. But we don't want to necessarily tie just the acreage of fires. We want to look at the impacts. And so winter 2016, 2017 was one of the wettest winters on record for much of the California region. And even several months later, we did see major impacts, of course, from the wine country fires that impacted Sonoma, Napa, Marin, and Mendocino counties in October 2017. And then in 2019, we had the high impact red flag warning that impacted much of the North Bay. There was a widespread power outage that impacted millions of residents throughout the Northern California region. So it just goes to show it only takes one fire to cause impacts to the population. It could be overall a quiet fire season, which 2019 overall was relatively quiet acreage-wise, but we still saw a lot of impacts associated with that single fire that developed in Sonoma County. And with that, that's really all that I have to share today, and happy to answer any questions folks may have.
Thanks, Scott. Let me pull up the questions here real quick. Someone was asking, Let's see. You mentioned that 2023 to 2024 is abnormal normal water year. Is abnormal normal a subdivision of above normal water year?
That was just more or less a play on the words from what I had in the previous slides. I said that California is normally abnormal, but this year it's a reversal where we are abnormally normal. So it's not a technical classification, just a quote unquote the assignment that I had on that.
And then someone asked, I guess it's more toward the latter part of your presentation, are we having more red flag warnings in the last few years in contrast to a decade ago? I'm seeking hard data.
So I don't have the hard data in front of me or the numbers in front of me. Each location, it may be very specific to any given geographic location in California too. We can have red flag events in Northern California versus or coastal areas of California versus Southern California, different mountain elevations as well. It all depends on the fuels. In order to hit critical fire weather conditions, I can advance back to that slide. For critical fire weather conditions, one commonality throughout California is that you need to have the receptive fuels as well as the low RH and high winds. So you can have a very dry day in California. Relative humidity values in the summertime afternoon could fall to 10 to 15%. But if the winds are calm, that doesn't represent critical fire weather conditions. You need to have both of those parameters contributing to critical fire weather conditions. But again, in terms of specific numbers, how that has trended over the years, I just don't have that information available, unfortunately.
And that person mentioned that we asked how to reach you, and I can follow up with them with your email and my email to just connect them.
Yeah, that works perfectly.
And then let me see this one. This is maybe more for me as well, for just these webinars in general, but someone was asking if we ever do a comparison between the actual precip that was received compared to the previous seasonal precipitation outlooks to give listeners a better sense for how much they wish to rely on the forecasts. I didn't know if you had any thoughts on tools or things that are out there or that we can share on these webinars, or it's something I can obviously dig up or keep working on for future webinars as well.
Yeah, so I guess I can comment on some of the Outlook products at least. So like the seasonal precipitation Outlook. This is not a numeric forecast, so it's not saying any part of the country is going to get X inches of rain. This is merely a probabilistic outlook of being within three categories: below normal, near normal, or above normal. So it's hard to compare. It'd be apples to oranges comparison essentially if you're looking at if you're trying to compare a seasonal outlook probabilistically versus what actually materialized with say a QPE map for example. So I have seen some comparisons that the Climate Prediction Center has done, but I just wanted to throw that caveat out there that it sometimes is very difficult to compare this product to reality just because this is based on just the likelihood of going to either of those three silos of being below normal, near normal, or above normal.
Great. Yeah, that's a great reiteration for those figures and how to read them. I guess one last question, and this is, I think someone was just clarifying on one of your slides for winter precip, California experienced 12 inches in February or March? If they wanted some clarity, just ask about that.
So I think they're probably referring to this graphic right here. So the Northern Sierra Indice during the month of February, which is an 8-station aggregate of stations in the Northern Sierra Nevada, they observed 12 inches of precipitation during the month of February, which normal during the month of February is 8.9 inches. I think that's probably what they're referring to. Maybe I may have misspoken. I apologize about that.
No, that's great. And I'll see if there's a few more, but I don't think I think we've answered most of the ones that were relevant here. But I'll follow up an email if any more come through, and I'll connect you with the person who was asking some questions about the red flag warnings and things like that.
Perfect.
With that, I'm going to go ahead and pass over to me real quick so I can show my screen and close out the webinar. With that, I want to say thank you all for joining us today. And thank you to our great speakers, Jeff and Scott. I hope you enjoyed their presentations, and thank you guys for presenting. As I mentioned, we'll try to take any other questions through email and connect the dots as needed if people need more information, and share the papers and things that Jeff was sharing. I'll mention again that the recording with a brief summary of this webinar will be available on drought.gov later this week, and usually it's up on the NIDIS YouTube channel even sooner than that. And with that, I'll say our next webinar is scheduled for July 22nd. And the QR code there is the one I shared earlier if you want to sign up and you're not already on our listservs or want to be on any other NIDIS listservs or drought alerts and things like that. With that, I'll say I hope everyone had a great holiday weekend and a great start to your week, and we'll see you guys next time.